Hello students, welcome to the classes. In this session, we will see few MCQs based on the chapter probability. Right, now let's see the first question. The probability of an impossible event is. We have seen this in the synopsis. Right, impossible event means what? The event which will never happen. So it will never happen means what? Its probability is what? 0. Right. Let's see the second question. If A and B are two events in a sample space S, then P of A union B is. See, there is a formula to calculate P of A union B. Okay, that is given by P of A union B equals to P of A plus P of B minus P of A intersection B. Right, now here you see in the P of A plus P of B, I am subtracting something, then I am getting P of A and B. So it means this has to be bigger, because bigger minus some value, you will get the smaller value. Right, so P of A union B has to be small. So this is less than or equal to P of A plus P of B, option 3. Right, let's see the third question. Okay, the probability of an event lies in, and as I told, the probability, okay, let's represent using P. This value is between 0 to 1, right? The value of probability is between 0 to 1, and probability can be 0. Yes, because for impossible event probability is 0. For sure event probability is 1. So we can write less than or equal to, less than or equal to. So here it is both side included, less than or equal to. See, if you have less than or equal to, we use square bracket. If you have less than, we use open bracket. If you have greater than or equal to, okay, we use square bracket, or this or this, depends. Okay, or even if you have greater than this or this. Okay, so now here you see both sides it is less than or equal to. It means both sides it has to be square bracket. From where to where? 0 to 1. Option A. Right, let's see the fourth question. If A and B are mutually exclusive events, then P of A intersection B is. See, mutually exclusive events means what? A intersection B is a null set, because mutually exclusive means what? No element common, no common element, no element in common, right? If there is no common element, the number of elements in A intersection B is 0. I mean, the number of elements is 0. So probability is also what? 0. Which option? Option 3, 0. Let's look into the fourth question. P of at least one of the events A or B. See, P of at least one of the events A or B. That means that is nothing but P of A union B they have asked. What is P of A union B they have asked? Now this question, let us see, the based on what, using Venn diagram, it becomes very easy to understand. So let's say this is A, let's say this is B. Okay, this inside part is nothing but A union B, and this outside part we have, let me do one thing, let me use a different color for that. Okay, so I'll take the different color. Okay, let me do one thing, let me erase it. Okay, we'll use different color so that you'll understand. Okay, so yes, now see, this is A union B, and the outside part is what? The outside part is nothing but A union B whole bar. A union B whole bar, except A union B. That is nothing but what? That is nothing but A bar intersection B bar. A dash intersection B dash, using De Morgan's law. Right? So now see what they have asked. P of at least one of the events A or B. That means A union B. They have asked P of A union B. Remember one thing, the probability of sample space is 1. This is total sample space, here it is. This total probability is what? 1. If you want P of A union B in that, in the total one, for if you want to get the blue lines part, I mean P of A and B, in the total one, if you remove the outside part, I mean this part, if you remove this part, you get inside part, right? So that means what? If you want to get inside part, P of A and B, you remove outside part. Outside part means what? P of A dash intersection B dash. So which option? Option, yeah, 2. 1 minus P of A dash intersection B dash. Or you can also do it like this. P of success is, I'll take it as A union B, plus P of failure. Failure means P of A union B whole bar. Success plus failure is equal to 1. I told you in the synopsis. Now, if you want P of A union B and plus P of, what is A union B whole bar? We can use De Morgan's law and we can write A dash intersection B dash equals to 1. Now, what is P of A union B? Now 1 as it is, plus term that side, minus P of A dash intersection B dash. So option 2. Right. Let's see the next question. In an experiment yields 3 mutually exclusive and exhaustive events. Okay, A, B, C, and such that, okay, see they are given some condition here, P of A equals to this, 2 times P of B, 3 times P of C, and then they have asked P of A. See what they are given, mutually exclusive and exhaustive. Mutually exclusive means there is no common element between A and B, or between B and C, between A and C. And exhaustive means what? Exhaustive means P of A union B union C should be equal to 1. In the synopsis we have seen. And P of A union B union C is given by the formula P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. This is a formula for this. This should be equal to 1. But here, as I have told, mutually exclusive. There is no common element between A and B. So this will be, these values will be what? 0. Why? Because there is no common element. So probability is 0. What is P of A? Let me do one thing. They have asked P of A, right? They have asked P of A. So let's keep P of A as it is. Now what is P of B from this? If you take 2 here, it divides, right? So this P of B we can write as what? P of A divided by 2. If you take 2 here, it divides. And here they are also given P of A is 3 times P of C. They are given P of A is 3 times P of C. Now if you take again 3 here, it divides. So what you can write? P of C. P of C can write as P of A divided by 3. Right. Now that should be equal to 1. Take the LCM now. Okay. LCM is what here? 6. Now I'll multiply 6 here. I'll multiply 3 here. I'll multiply 2 here. 6 plus 3, 9. 9 plus 2, 11. 11 times 11 by 6 times P of A. That should be equal to 1. It implies. Now see. Take 6 here. Take 11 here. What is the P of A value? 6 divided by 11. Right. So which option? Option 3. So this formula is very important. Remember this formula. Okay, P of A union B union C. Right. Now let's see the 7th question. If A and B are 2 mutually exclusive events in a sample space S such that P of B equals to 2 times P of A and A and B are exhaustive events, then P of A. What is meant by exhaustive? Exhaustive means the probability of their union should be equal to 1. So exhaustive events means P of A union B should be equals to 1. But we know P of A union B formula. Okay, in the previous problem we have seen P of A plus P of B minus P of A intersection B. This is a formula for P of A union B. This is equal to 1. Now see, P of A I'll keep it as it is plus P of B. P of B is what? 2 times P of A. I will write 2 times P of A minus. This value is 0. Why? Because they are mutually exclusive. Means there is no common element. So probability is 0. This equals to 1. P of A plus 2 P of A. 3 P of A equals to 1. So P of A equals to what? 1 by 3. So which option? Option 2, 1 by 3. Right. Now let's look into the 8th question. If A and B are two mutually exclusive events, then the relationship between P of A bar and P of B is. See, here what they are told, A and B are mutually exclusive events. Now let's do one thing. Let us consider P of A union B. This P of A union B, okay, probability value is always less than or equal to 1. Right, probability of A union B is always less than or equal to 1, but we know probability of A union B is given by what? P of A plus P of B minus P of A intersection B. Right, this is always less than or equal to 1. We know the formula for this. I am just substituting. As they are mutually exclusive, I will take this probability as 0. Now what do you get? P of A plus P of B is less than or equal to 1. Now P of B less than or equal to plus P of A that side minus P of A. So what do you get? P of B is less than or equal to 1 minus P of A is nothing but P of A bar. P of A bar is nothing but what? Failure. 1 minus probability of success is nothing but probability of failure. So P of B is less than or equal to P of A bar. So which option? Option 2. Right. Let's see the next question. If A, B, C are three events in a sample space, then any three events in a sample space, then see they have asked what? P of A intersection B union C. Okay, to understand this, let's do one thing. Let's consider the the Venn diagram. There are three events here, A, B, C. I'll draw three circles here. Okay, A, B, C. Okay, now let's do one thing. Let me take the different colors so that you understand easily. Right, now see, here they are given A intersection B union C. First I will mark B union C. B union C means this is B union C. Right, union means what you will do? Union means you will shade it completely. Okay, that is B union C. Now next what we have? Next we have what? A intersection. A intersection means with whatever we have marked now, okay, that marked region, what is, out of that marked region, what is common with A? You can see here, this part, okay, this part is common with A, right? This marked region is common with A. Now here you see this marked region, I'll just try it again. Yeah, this marked region consists of two parts here. See, like this, one part, and it actually, this is two parts, right? Now see, this, if I take, let's name the region here. Let's name the region as 1. This region I will name it as 2, and this region I will name it as 3. Okay, now see, you want the region 1 plus 2 plus 3. These three regions you want. Okay, now 1 plus 2 plus 3. See what I can do. Let's look into the options here. P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C. Okay, this means what? P of A plus P of B plus P of C. They are adding all the probabilities, then they are subtracting A intersection B. This part they are subtracting, but we want it. This part they are removing because you need A intersection B, right? But they are removing this part in the answer. So this is A intersection B. Intersection means what? Common part. Between A and B, the common part we should have. We should have that part, but they are removing. So this is not your option. And this is not your option because they are multiplying here. Two probabilities they are multiplying. Okay, this obviously is not the option here. Why? Because only in the case if the B and C are independent events, we may use it. We may use it and we may get or we may not get the results. But have they given independent events? No. If they have not given independent events, don't use P of B into P of C. Okay. Now let's look into these two options. Either of these two options is correct. Let's see how. Okay, now here in let's do one thing. Let's say they are given A intersection B. P of A intersection B is what? See, in the A intersection B part means this is your P of A intersection B part, right? It contains how many parts? The part 2 as well as part 3. So this contains part 2 plus part 3 plus P of A intersection C. A intersection C means this A intersection C means what? This part 2, this is your part 2, right? And part 1. It contains part 2 and part 1 minus P of A intersection B intersection C. That means common to all of them. This part is common to all of them. That is nothing but part 2. So I will remove part 2. Now see here, plus part 2 minus part 2 cancel. What do you get? 1 plus 2 plus 3. 1 plus 2 plus 3 is nothing but what? P of A intersection B in and C. Right. So which option? Option 3. Right. Or you can also use, okay, the distribution property here. What is meant by distribution property? You have probability of A intersection B union C, right? Okay. Now what I can do is, if I use distribution property, what we get? P of A intersection B, P of A intersection B, then union A intersection C, A intersection C. Now let's think this is X and this is Y. Okay, now what is P of X union Y? We know that P of X is A intersection B plus P of Y is A intersection C minus P of X intersection Y. X intersection Y is what? A intersection B intersection A intersection C. Right. Now see, P of A intersection B plus P of A intersection C minus P of what is A intersection B intersection A intersection C. In both of them A is common. So I'll just do one thing, and all of them are intersections. In that case we can write this whole thing as A intersection B intersection C. Right. So which option? Obviously option is what? Option 3. Right. Now let's see the next question, that is 10th question. They have asked if A and B are two events, then they are given some expression here. Let's see how to solve this. See, they have asked P of A intersection B bar union, okay, union A bar intersection B. Right. Now let's look into Venn diagram, which makes it easy to solve this. Okay. See, if this is A, this is B. Now see here, only this part, whatever this part you have, this is nothing but A intersection B bar. That means contains A but not B. Only in this part you don't have A, you don't have B, but you have A. If you take this part is nothing but what? Doesn't contain A but contains B, A bar intersection B. Now here they have asked what? P of A intersection B bar union P of A bar intersection B. It means together these two, together these two parts they have asked. Now see here, if I take the Venn diagram and if I mark the whole thing, that is nothing but what? A union B. In the A union B, see, in the A union B, they are leaving just this middle part. This middle part they are leaving, right? If you leave this part, it means P of A union B. If you leave the intersection part, you will get this, right? So in the P of A union B, I will leave P of A intersection B. It means which option? Option 1. Right. Let's look into the 11th question. If A and B are what? The two events in a sample space S such that P of A is not equal to 0, then they have asked what is P of B bar A. It is direct question based on conditional probability. It is given by P of B intersection A divided by P of A. But P of B intersection A is same as A intersection B divided by P of A. Right. So which option? Option 2 is correct. It is just a definition of condition probability. Right. We have seen this in synopsis. Let's look into the 12th question now. Okay, now see here what they are given. If P of B bar A is less than B, see P of B bar A is less than P of B, they are given. The relationship between P of A bar B and P of A is. Now see here, what is P of A bar B? We can write it as what? P of A intersection B divided by P of B. Right, now if you take this term here, what do you get? P of A bar B equals to P of A bar B into P of B equals to P of A intersection B. Right, I'll call this as equation 1. Similarly, what is P of B bar A? It's nothing but what? P of A intersection B divided by P of A. Right, now if you take this part here, P of B bar A into P of A, if you take this here, you get equals to P of A intersection B. Right, let me write it again, P of A intersection B. Right, now look at equation 1 and 2, both RHS are P of A intersection B. It means you can equate these two. So P of A bar B into P of B should be same as P of B bar A into P of A. Right, now here they are told P of B bar A is less compared to P of B. See, P of B bar A is less, this is less, this is more. But still the values are what? Equal. That means this has to be less, this has to be more. Then only they will become equal, right? Less into more. If you have both more on what? RHS or LHS. If you have both more on LHS and both less on RHS, can they be equal? Less into less, obviously you'll get less. More into more, you'll get more. So to balance, okay, if one quantity is less here, one quantity has to be more. This means P of A has to be more, P of A into A bar B has to be less. So which option? P of A bar A is less than P of A, because P of A is more, you can see here. Right? Let's look into the 13th question now. Okay, so the probability of getting head or tail when an unbiased coin is tossed. A direct question. How many heads you have? One head. Okay, how many total number of coins you have? Total number of faces you have 2. Probability of getting head is 1 by 2. What is probability of getting tail? 1 by 2. They have asked probability of getting head or tail. This means probability of H union T. Probability of H union T. It means R means union. Remember one thing. R means union and means intersection. Now here this is given by P of H plus P of T minus P of H intersection T. P of H is 1 by 2. P of T is 1 by 2. But H intersection T. Do you get head and tail at the same time when you toss a coin? If you toss one single coin, do you get head and tail at the same time? No, it means its probability is what? 0. This is 0. 1 by 2 plus 1 by 2. That's nothing but what? 1. So what option? Option 3. Option 3, 1. Right. Let's look into the 14th question. The probability of obtaining exactly R heads, okay, and N minus R tail when we toss N unbiased coins. See, this is based on binomial distribution. N number of coins are tossed, or one coin we can toss it N times. So for that, probability of x equal to x is given by what? NCx p raised to x q raised to n minus x. Right, here probability of x equal to, they have given R heads. I will write R here. The value of x is nothing but R. So NCR, and probability of getting head, what is that? 1 by 2 raised to x is nothing but R. And Q is what? The failure. Getting head is success, means failure is what? Getting tail. What is probability of getting tail? 1 by 2 only raised to n minus, what is the value of x? R. Now see here, NCR. Now see, 1 by 2 raised to R, 1 by 2 raised to n minus R. We can write as 1 by 2 raised to R plus n minus R, because a raised to m into a raised to n, a raised to m plus n. Now minus R plus R cancel. NCR into 1 raised to n is nothing but 1. So we can write NCR divided by 2 raised to n. NCR divided by 2 raised to n, right? Which option? Option 3. Now let's look into the 15th question. A coin is weighted so that head is twice as likely as to appear compared to what? Tail. So when such a coin is tossed, once the probability of getting tail is. See, a coin is modified. It's a biased coin. It's being weighted such that if you toss coin, okay, there is 2 times more probability of getting head compared to tail. It means probability of tail here, if it is x, probability of head is nothing but what? 2x. Now if you toss a coin, either you will get head or you will get tail, right? So probability of head or tail, okay, head or tail is nothing but what? Either you will get head or you will get tail. That's nothing but P of h plus P of t minus P of h intersection t, right? So what is P of h union t now? Okay, P of h is what? X, 2x it is. P of t is what? X minus P of h intersection t is nothing but 0. You don't get head and tail together. So this is nothing but what? 3x, right? And this 3x has to be 1 because these two events are what? The exhaustive events. Okay, if you take the union, I mean if you toss a coin, either you will get head or you will get tail. You are getting all the what outcomes here. So probability of what? Sample space you are getting, like what is the sample space? Head or tail. You can see here you have head or tail here. So probability of sample space is 1, or you can equate this to 1 directly, right? 3x is nothing but 1. So what's the value of x? 1 by 3. What is x? Getting tail. What they have asked? Probability of getting tail. So which option? 1 by 3, option 2.